Hey guys, it's time to talk about gases. So, the nature of gases. Gases expand to fill the container completely. They are a fluid or they flow. Gases have a low density. They're less than 1,000th the density of the equivalent liquid or solid. Gases are compressible. Since gases have a low density, that means there's a lot of empty space in between the gas molecules, something good to remember, so that they can be compressed or made into a smaller volume. Gases effuse and diffuse. So, ideal gases are imaginary gases that can perfectly fit all the assumptions of the kinetic molecular theory. Gases consist of tiny particles that are far apart relative to their size. Collisions between gas particles and between particles and the walls of the container are elastic collisions. This is kinetic molecular theory. No kinetic energy is lost in elastic collisions. Gas particles are in constant rapid motion. They therefore possess kinetic energy, the energy of motion. There are no forces of attractions between gas particles. The average kinetic energy of a gas particle depends on the temperature, not on the identity of the particle. Again, this is average kinetic energy, not their velocity, just their kinetic energy. Pressure. The pressure is the force exerted by the collisions of the molecules with the walls of the container. And we have about 4 units that you need to know. There is a 5th one, and that's pounds per square inch that you're familiar with from pressure in your car tires or something like that. But a Pascal is abbreviated as PA. It's the SI unit for pressure, and it equals 1 Newton divided by a meter squared. Milliliter of mercury, mmHg, is the pressure that supports 1 millimeter of a column of mercury in a barometer. Atmosphere, ATM, is the atmospheric pressure at sea level at 0 degrees Celsius. And torr is 1 millimeter of mercury, named for the scientist who invented the unit. Standard pressure is 1 atmosphere of pressure, or 101.3 kilopascals, or 14.7 pounds per square inch, 760 millimeters of mercury, 760 torr. All of these are standard pressure. Measuring pressure was first done by Evangelista Torricelli in the 1700s, or 17th century, and he created a device called a barometer, and it measures the weight of air. So, an early barometer was the device shown in the picture. It shows that as the pressure of air is pushing down on this open container of mercury, there's a vacuum here with no atmosphere at all, and the height of this column, or how high this column of mercury is dependent on the pressure outside of the system, which would be 760 millimeters of mercury. So, what temperature do we do all gas law calculations in? Not Fahrenheit, not Celsius, but Kelvin. That is correct. To convert from Celsius to Kelvin, you add 273 to the Celsius temperature, and that will give you Kelvin. You have to do a little bit of changing around to get from Fahrenheit to Celsius. You should figure out how your calculator, I think, has a built-in feature to do that for you. Mostly you'll have to convert from Celsius to Kelvin, and remember to do so without being told. So, we have a thing called STP, or standard temperature and pressure, and that's either 0 Celsius or 273 Kelvin, and 1 atmosphere pressure, or 101.3 kilopascals, or 14.7 pounds per square inch, or you get the idea. So, standard temperature and pressure is telling you the conditions for both the temperature and the pressure. So, that concludes this one. Of course, we have a lot of problems you should be able to work, and we will be practicing a lot of those in class. Good luck.